Now, here's what we're going to talk about tonight. We're going to talk about serverless Spring, but before we get started, just, again, title slide, this is who I am. Here's where you can email me if you have any questions. Feel free to ask all the questions you want, but if you don't get your questions, it's going to be hard for me to hear you if you ask in here, so just feel free to interrupt me, but speak loudly if you do. And if you don't get your questions in before I'm out of here, feel free to email me. I'll do my best to get back to you. I can't promise a timely response, but I'll do my best. Here's where I live on Twitter, where I tweet about almost anything that could happen, including more recently some of my travel complaints, and I think there was something about the discovery of gas on the planet Uranus, but other than that, I mean, I tweet about all sorts of stuff here. And then where I live on GitHub, and you might find some stuff pertaining to this talk or pertaining to other topics you're interested in. It's sort of my junk drawer of where I drop everything for the most part. All right, with that said, setting the stage, I need a show of hands. How many of you have worked with Spring? I mean, this is a Spring user group, but I can't assume everybody has. Okay, how many of you have worked with Spring Boot? Awesome. How many of you have worked with any flavor? It's a big umbrella project, mind you, but something under the Spring Cloud umbrella. All right, so I'm assuming those who didn't raise your hand, you're just tired of raising your hand, or perhaps you haven't. How many of you have worked with Spring Cloud Stream, but getting a little bit more specific? All right. And I ask these questions just to kind of get an idea of where everybody else is at, so I kind of know how to kind of gauge the rest of the talk, and I can kind of tweak little bits of it as we go along and emphasize certain parts. Obviously, a lot of what we talk about when we talk about Spring in 2018 has to do with Spring Boot. And so it'd be very weird for me to take the podium and present to you anything that did not have Spring Boot involved. And that's why I asked about that. I asked about Spring Cloud just as a general statement, but more specifically, there are places in Spring Cloud Stream where what we're going to talk about tonight, specifically Spring Cloud Function, plays a role. So I just had to ask about that. Well, here's what we're going to talk about. We're going to talk about serverless in general, kind of a general statement. What's it good for? Why do you care? Why is this important? What does it do? What does it mean? Then we're going to get more specific into Spring Cloud Function, and then we're going to talk about kind of a specific use case of deploying them to AWS Lambda, and I'll talk a little bit about that toward the end. And I got this really cool thing I want to show you toward the end. I hope it works. That'd be awesome. So what is serverless? Now, if you're like me, when you first started hearing the word serverless, you tried to Google it, you tried to talk to people, and I got all sorts of mixed answers on this. Every time I talked to somebody, or every time I Googled it, or every time I found an article on it, I heard a different answer. And I kid you not, even today, just for grins, I Googled again to see what people thought serverless was. And interestingly enough, they're still giving the same answers that were completely different than my understanding of it. And when I first heard of serverless, I thought it was just some stupid thing where we're going to build entire client-side applications up that just do nothing but consume APIs that are provided by someone else, like Google or Amazon or Facebook or what have you. And I thought, well, that's interesting, but how much are we going to really get done with that? And to some degree, what I just said may be somewhat true, but that's not really the kind of the gist of it. The real understanding that I place on serverless now is completely different than just borrowing someone else's APIs. And so if there is no server, then where does my code run? And does anybody here, I know at least one of you do, but does anybody here have ever heard or know of Dr. Dave Sire? Yes, Dr. Sire, I heard him say in a meeting one time, and it was so funny, and it's funnier if you know Dave. It's a lot funnier if you know Dave. It's hilarious to me, but it's funnier if you know Dave, if you hear his accent in your head. He has this nice English accent. And Dave, just to give you a little bit of understanding for those of you who've never heard him speak or never met him, a few years ago, he was one of 7 people on the panel, on the keynote panel at one of the Spring One conferences. And since there were 7 of them, they sort of started calling themselves the 7 Dwarves, and Dave got the moniker of Grumpy. Now, Dave's a really nice guy. I like Dave. He's a really friendly guy once you get to know him, but he does come off as being kind of grumpy sometimes. And so if you picture this man with glasses, sort of balding, English accent, kind of grumpy looking on his face, he says, so what does this mean, serverless? I mean, we're not stupid. Of course, say it with the accent. We're not stupid. There's a server. What is it? What are we trying to say here? And don't panic, there is a server. That's good news. Has to be. There has to be a place where we run this stuff. But the truth of the matter is, there are servers, but you don't care. You don't need to manage them. Someone else does. You don't need to do capacity planning on them. That's taken care of by the platform. You don't need to scale them up or down as need be. As usage increases, you don't need to think, oh, well, it's time we throw a few more instances at it. You don't need to do that. Likewise, when things start getting slow, you don't need to start scaling them down. It gets taken care of for you. And they don't even need to always be running. In fact, in that scale down scenario, you could find yourself with 0 instances running. Imagine you have some functionality that is only required once a day, or every so often, maybe once or twice a month it gets invoked. It's useful, it's important, you need to have it, you just don't need to have it all the time. And if you're running this on a server somewhere, if you're hosting a constantly running API that offers this functionality pretty much anywhere, you're paying for that uptime. You're paying and maintaining and making sure that this thing is up and running. And if it's a constantly running application that not only gets invoked once or twice a month, but when it does get invoked, it gets beat up on. It gets smacked down really bad because now suddenly everybody's using it at that time. Now you have to worry about scaling the thing. You either have to have several hundred instances ready to handle the traffic that's coming to it, and then scale them down yourself when the traffic goes away, or you just leave them up and running and you're now paying for all that processor when the rest of the month it's not being used. It's just simply not there. And it comes and goes, you don't know when it's going to happen. Good news is there are servers, but you don't think about them. You don't think about it in those terms. We start thinking about things in smaller units. So this is this whole serverless Spring, we start thinking about things in functions. So this slide is almost talking about microservices. We start thinking about things in smaller units of work, and we start thinking about things in smaller units of work, we can reason about them easier. We can test them easier. We can maintain them easier. And it's just a natural fact that once you start breaking things down into smaller modules, those individual modules are easier to deal with. They're easier to reason about, think about, understand, and share. We know this without going into any sort of microservice architecture or functional architecture. We know this because writing unit tests against a method is easier than writing integration tests against multiple objects. And that's even easier still than writing a full-blown acceptance test against the mass of your application. The smaller something is, the easier it is to understand, reason about, and work with. That's the reason why I hope everyone here understands the whole refactor extract method. Because when you do that, suddenly you have something easier to understand. Well, that's great. As I said, they're easier to reason and test about. And as a microservice, they're more focused. Microservices are more focused on a bounded domain. The idea here is, if you have like a e-commerce system, you have domains that represent products, domains that represent customers, domains that represent orders, but even with picking one of those out, we have products. A bounded domain says that you may view a product in terms of inventory. That's one bounded understanding of that domain. But a different part of your application may have a different understanding of what products mean. They may understand it in terms of, not of inventory, but in terms of pricing, or another one in terms of who the suppliers are. And you have different understandings in these bounded domains. So by not only breaking it down to individual domain types, you break it down to individual bounded domains, it's even further and easier to understand. But that's microservices. That's not even talking about functions. Instead, we're talking about we're breaking it down to a bounded task. We're focused on something even smaller. We're focused on trying to figure out, how do we solve this particular problem? And it's easier to think about, easier to reason about, easier to test, easier to scale, easier to everything, the smaller it gets. So the next couple of slides I'm going to apologize for, because they're going to be a little misleading, and I have to explain to you that they're going to be misleading, otherwise people freak out on me and think, oh, he's nuts. No, the next couple slides are extreme scenarios that I probably would never actually see in a real-world application. They're just an extreme take on this. And as I was explaining to Rob earlier today, you caught me schedule-wise in the middle of coming up with better diagrams. They just didn't make it into this slide deck. So we've been thinking in terms of applications for years, decades, thinking in terms of applications, things that we deploy as monoliths, things that we deploy typically as Java developers, we deploy as WAR files, maybe jar files, or heaven forbid, ear files. We deploy these big, massive things into some application server and wish them well. And the problem with those big monoliths is the opposite of what I said for smaller units. We have something larger we have to reason about. We have something larger we have to scale. So if even one little piece of this little tiny corner of this monolith is causing us grief from a scalability standpoint, the only option we have is to deploy more instances of this monolith. It's more complex to test. Not to say you can't test things at a unit test level or even an integration test level with these, but as a mass monolith, you have to test it in a greater scale. You have to make the technology decisions for it, for the entire monolith. And in an extreme case, I mean, obviously you choose between one library or another, one database or another, but a more extreme example is you're choosing a platform, you're choosing a language. You can choose between the JVM or you can choose .NET. And whichever you choose is not a wrong answer, but you've made that choice. And it's really hard to make a different choice for that monolith without starting over. And so microservices have helped with this. We start breaking our monolith down into 2 or more mini different microservices, each one targeting a specific bounded domain. And when we do that, we have now something smaller to think about, something that's more focused on that bounded domain, so we're not really, when we're developing against that, we don't have to necessarily think so much about what's happening in the other microservices. We focus on that service, we focus on its contract perhaps with the other services, but that's about as far as it goes. We can test it individually, we can scale it individually. If one of these services is causing us scalability issues, we scale it up, but we leave the others alone. We can make independent technology choices. We could do some of these in .NET. We could do some of these in Java. We could do some of these in Ruby. We could do some of these in, heaven forbid, PHP. But you could do them in different decisions. You can make completely different technology decisions if you so choose. I'm not saying that's a great idea. I'm just saying you have that flexibility if you need it. Kind of a sidebar here, has nothing to do with the rest of this talk, but I'll just toss it out there for grins and giggles. If you are using Spring and you are using, of course, Java to develop your microservice architected application, and you find yourself in need of some .NET microservices for whatever reason, there's a project out there called Steel Toe that essentially gives you client-side components for .NET to interact with Spring Cloud services, such as Eureka and Hystrix and the configuration server. So just by the by, if you're interested in that, you can look into Steel Toe. But what we got is, by breaking this down, we got all these benefits of breaking it down. Now, we did get some complexity. It's not a free lunch, because now we have a distributed system. These things have to talk to each other. They have to coordinate with each other. And so we have a different kind of complexity that we've introduced because they are a distributed system. But we have some benefits as well. If we were to take this to its extreme, and again, this next slide is the one I'm really apologizing for. If we were to take this to its ultimate extreme, we could break this down even further, not into a bounded service, not into a bounded domain, but into a set of bounded tasks. Now, in no way whatsoever am I suggesting that you should do this. This is extreme. In no way should you ever necessarily break down every microservice you've come up with even further into individual functions. I'm just saying you could. So this slide is a little bit far-fetched. What's more realistic is perhaps something like this. Well, let me back up. This slide is not exactly it, but this is almost what I want to talk about. When we are talking about microservices, and this is not functions here, this is just microservices, one of the problems that we have, and it's actually a problem that I encountered when I first started dealing with microservices, is how do my clients talk to them? My clients, whether it be my desktop or my phone or my tablet or whatever, they're going to need to find these microservices and communicate with them. How are they going to do that? Are they going to, is my JavaScript code, is my iOS code, is it going to be littered with all these URLs for all these individual microservices? Because that seems horrible if it is. First off, they know too much about the back end, but they also know about individual instances of services. If these things have multiple instances, each one may have its own URL and or port. how is my client going to deal with this? And the answer to that is real simple. There's actually a lot of solutions that come out of this one idea here. Is one of them is we just have a gateway. We have this client-side gateway. And that could either be done with Netflix Zool, or it could also be done with a relatively new project called Spring Cloud Gateway. And what that's going to do for you is it's going to give you this one front end, this one API that your clients can talk to. It knows how to take those requests and dispatch them off to whatever microservice they're intended for. And that's great. It actually solves some security issues as well. It helps you authenticate against the gateway, not so much against each individual service. The gateway works, does the security with the services on your behalf. It's really sweet. It also solves, just while we're here, I might as well mention it's one of my favorite things it solves is it helps you get away with the whole cross-origin issue. If you did have a JavaScript client that's consuming multiple microservices, chances are that JavaScript code did not come from any one of those. And therefore, when it starts making calls to it, you would have a cross-origin issue. But if you serve everything, including the JavaScript through the gateway, there's no cross-origin issue. It's all coming from the same place. It's kind of sweet. Well, taking that same idea and applying it to functions, what if we did a whole bunch of functions, each one doing its job, and then we have a service gateway sitting in front of it, essentially exposing a microservice that aggregates all these functions up into a given microservice that is part of, perhaps you could take the same picture and duplicate it for different other domains throughout our system. And so that's a more realistic scenario. And you'd probably still have some just good old-fashioned microservices that don't have functions behind them. And you might have some that are mixed. They have some of their own functionality, but they delegate off to functions for some other bits. The reality of it is you're not going to build an entire application full of functions, although that is possible. So this steps into another kind of view of functions. It's the word frameworkless. I've heard it said a couple of times. I'm just going to go ahead and use the word, frameworkless. Not serverless, frameworkless code. The idea that functions are just functions. And when I say functions in the case of Java, I'm talking about Java util functions, which could also mean consumers or suppliers. They're just functions. They just do some job. They don't know how they're going to be used. You write a function, it gets consumed somehow. It may be an HTTP request. It may be something else. It may be part of some sort of data flow, some sort of stream of data. It may be part of something else. There's a lot of different ways these could be consumed, but when you code them, you're not coding them to any specific API or any specific framework. And to put this in perspective, if you're building a Spring MVC application that ultimately exposes some sort of REST API, you are choosing, when you write that controller, that you're going to handle HTTP requests. It's just the way it is. You wrote a controller. It's handling HTTP requests. That's what its job is. In contrast, though, you write these functions. They just take data, they return data. They have no idea where the data came from. They don't have any idea where it's going next. They just know that they are supposed to process something and return a value. And once it gets deployed into the platform, once it gets deployed into the serverless environment, something else determines who invokes them. So they don't know how they're going to be used, nor do they know where the data is going. It could be a REST endpoint, sure. It could be part of a processor, like in Spring Cloud Stream. It could be part of a processor or a source or a sink. They don't necessarily get coded to any specific framework or any specific use case. So just kind of a relatively new diagram that looks really horrible on the projection. What you may not see very well is there is a very faded gray line going right through the middle of underneath all those that essentially acts as a rabbit or Kafka binding. But the idea is if you're using Spring Cloud Stream, this is not functions at this point, but if you're using Spring Cloud Stream, what you typically have is a bunch of microservices that are all tied together through a stream. So there's some source microservice that produces data. It may get it from some other place like a mail server. It may pick up data from a database. It may pick it up from a message broker, but it's a source of data, and it enters that data into the stream. And then you have 0 to many processors. They are additional microservices that are deployed independent of each other who know nothing about where the other ones came from or what the other ones are doing. All they know is they're receiving some data. They are to churn on that data, and they are going to return the data that's going to go back into the stream for the next thing in line. And again, it could be another processor, or it could be a sink, and the sink is the final stop. The sink takes whatever data comes in, and this is the end of the line. It either writes it somewhere, sends an email, sends it to a database, maybe sends it back into a message broker somehow. But this is the end of the line for that particular stream processing. Well, the way that Spring Cloud Stream has worked up till today, and still works, is you write these as Spring Boot applications. And they're very simple Spring Boot applications, but they're Spring Boot applications that have a little bit of Spring integration mixed in with them. So if you've ever worked with Spring integration, you'll know what I'm talking about. But you'll define essentially as like a service activator, typically as your source. Well, not a service activator as a source, usually as a processor or a sink, but regardless, it's going to pick up the data from somewhere, and using the Spring integration annotations, you're going to describe what it's supposed to do with it or where it's supposed to get it from. Same thing with a processor, same thing with sink. It's just a bunch of Spring integration code, but instead of defining your integration flow as a single application, you define it as individual little applications. And each one of these can be deployed independently, understood independently, scaled independently. They are just individual microservices. What makes Spring Cloud Stream a little special is you're writing microservices that don't use REST necessarily. They talk to each other by these back-end binders, which they themselves don't even know about. Now, as I'm talking about Spring Cloud Stream, I can't help but think to myself, that sounds a little bit like what I said when I talked about functions. Data came to them, they did something with it, and they wrote it out. They didn't know where it came from, and they didn't know where it's going next. Which I found to be interesting, because as I talked about that and as I thought about it, we find out that in fact Spring Cloud Function itself does the same thing. Now, I don't know what the official shape is. I mean, I know for microservices we like hexagons. I don't know if there is an official shape for functions, so I just commandeered the diamond shape, if that's all right with everybody. And so we have the same idea, but we do these as functions. We have a source function, which probably would have been better labeled as a source supplier. We have 0 or many processor functions, and then we end with a sink function, or better, a sink consumer. And there's no reason that these could not be individual functions. They are written, though, to not know or care about that. They are just functions. These very same functions that process some data for a stream, the exact same code can be used to handle an HTTP request, because it doesn't know where the data comes from. It doesn't know where it's going next. I've learned a lesson here that I need to use a darker gray on that background box, because it looks great on my screen. It looks horrible up there. So why do we care? There's an economics to anything we do and any decision we make, and so I've tried to kind of capture in as succinct terms as possible why you should care about functions as a service or serverless. And it comes down to these things here. Obviously, when you talk in terms of complexity, monoliths, they may have their own complexity, their own domain complexity, their own complexity because, you know, whoever the bozo is on your team wrote some bad code, you know who they are. But they're fairly simple. They don't have any sort of distributed application complexity. They're fairly straightforward in that regard. Microservices, in contrast, they are a distributed application. They're simpler in some ways, but their complexity kind of adds up because there is, in fact, it's a distributed application. It's a distributed system. You have to worry about things like latency, and you have to think about how these things are going to be coordinated together. And typically, in a microservices world, you do have some help with that. You have some infrastructure. You have some sort of, trying to think what the word I'm looking for is here, but you have some other services that assist with that. Functions get even more complex because it's an even more distributed system. We've taken something that was distributed and we distributed those things. It's even worse in that regard. But from a development standpoint, once your monolith gets past hello world, suddenly it gets more complex to develop. And I heard it said that the first 80% of a project takes about 80% of the time. And the last 20% takes the other 80% of the time. And because it gets harder the bigger the application gets. It gets more complex the bigger your monolith gets. And it suddenly becomes a situation where you're trying to add on this new feature or even fix a problem. You break something else. And it's just because you have this huge thing that just gets in each other's way. But it gets simpler with microservices because we have distributed, because we have broken them down, it is not as costly in terms of development. We can focus just on what this API does, what on this bounded domain does. We don't have to think about what happens outside of it too much. We have to concern ourselves really only with how it's used, what the contract of that API is, but not so much on what the other microservices might do or what we might do to break them. As long as we stick to our contract, we can rest assured we're not going to break anyone else. And then there's functions. Functions get even cheaper still because they are even smaller than that. They, as a smaller unit of work, the development understanding of them is not just a bounded domain, it's a bounded task. It's a specific task within a bounded domain. It's even easier to reason about. Scalability works in our favor too for functions because with a monolith, as I said, if you want to scale up a monolith, you scale the whole monolith. You create more instances of monolith. Typically, in like a cloud environment, what that means is you're paying for more server time on AWS or Google Cloud Platform when you deploy these monoliths. In your own data center scenario, you're buying more hardware or leasing more hardware. It gets more costly. Microservices make that a little bit better because we don't have to scale the whole thing. We scale the things that cause us pain. We leave the other ones alone, and it's less costly. And then functions, it's even more so for reasons that come into the next column, where the runtime costs of running a monolith require, again, more servers that are running all the time. Microservices require a few servers, but they still have to be running all the time. Functions don't have to be running all the time. They will scale up and they will scale down as needed, and you're only paying for when they're running. You're only paying for the instances as they run. The billing for those, at least with AWS, comes down to essentially, by default, the way I've set mine up anyway, 30 seconds at a time. You're only paying for that 30 seconds of CPU at a time, and if nobody has called you in the last month, which is often the case with my little toy functions that I play with, I'm not getting billed for that. And right now, my entire Amazon bill, which includes me storing every photo I've ever taken ever, plus a couple of functions that I invoke, it's essentially a rounding error. In fact, I think because I call it so infrequently, I'm getting it for free because you get so many million calls for free with AWS as a developer. So that's pretty cool. But even if I was getting invoked quite frequently, it's going to be still far less than something that's running all the time, even if nobody's using it. So this is where Spring Cloud Function comes in. Spring Cloud Function is a Spring module, Spring project, that enables you to build essentially Spring Boot applications that help you develop functions, individual functions that can be deployed into Lambda, into GCP, into potentially Azure, and as well as a few other options we'll talk about later. Now, I've got a few slides on this, but the slides aren't as fun, and this is what I'm going to do. I'm going to write live code, which could get scary, by the way. Hang tight. I'm going to probably screw something up. So I've already gone to the trouble of creating the project up front, and the reason I chose to do that is because a couple of reasons. The main reason is that in its current form, Spring Cloud Function is not GA yet. It is still very much a couple of milestones in, like milestone 5, I think, something like that. And so as a consequence of that, I can't just go into the Spring initializer and check a checkbox and have it just show up magically in my POM file. So I have to do it manually, and every time I do that manually, things go really bad. So I've got one that works, and I copy it. It's just the way we used to do things before we had the initializer and had checkboxes. So you'll remember those days. It was a lot of fun. I also, I discovered quite by accident, I was actually giving this talk somewhere else, and I was thinking, I was being all brave. I'm like, hey, Spring Boot 2.0 came out. Let's use this stuff with Boot 2.0. And it did not work. And in fact, the only way I ever got it to work was by using a snapshot build, which there may be a milestone now that makes it work, but at the time, I could only get it to work with a snapshot build. And so the only thing I'm going to play free and loose with tonight is I'm going to use that same snapshot build. So Cross your fingers. This could go really bad. But just to get you started, I'll show you what I did put in my POM file, rather than checking some checkboxes. I am working with Spring Boot 2.0.1, so that's good news. Boy, that did a horrible thing. You should come see my screen. It looks better. I won't zoom in anymore. That's what I'm not going to do. That usually works better. I'll do this. This should work. There we go. There we go. I should never do that again. But here I'm using Spring 2.0.1, so that's the latest Spring Boot. And then down here I've set a couple of properties. The properties that are of interest, gosh, I'm tempted to zoom in right now. The properties that are of interest are the Spring Cloud Function version, which as you see is 1.0 build snapshot. And then I'm using Reactor version 3.1.2. The reason I'm using Reactor is not going to be obvious at first, but eventually it'll come in. I've just gone ahead and included it for grins right now. Down here I have a couple of other dependencies. I have Spring Cloud Starter function web. And the reason that exists is because I'm going to essentially use this. This is a web adapter for Spring Cloud Function. Because remember what I said, when you write these functions, they don't know how they're going to be used. They could expose an API. They could be part of a stream. They could be used as something else. Well, this adapter is what's going to enable me to poke at them as a REST API by tossing this adapter on there. It's especially good for development purposes. Even if you're going to ultimately use this in some other way, having this dependency in there for development purposes is really nice because you can just use curl or HTTP and poke at it and see what happens. So that's the main dependency. There's a couple of others I'll show you when we get back to the slides that you might be interested in, but that's kind of the main one I'm going to start with. That's going to transitively bring in one of those other ones I'm going to mention later. And then we got this Spring Boot configuration processor. I honestly thought I knew why that was in there, but when I put it in there, it didn't fix the problem I wanted, so it's just there now. So ignore that. Actually, I know what it does, but it has nothing directly to do with Spring Cloud Function, so ignore that for the moment. I thought I knew what it was going to do, and it had no effect whatsoever. That was very disappointing. And then down here, I just got some other general stuff. I got some of the Spring Boot stuff. I started this as a Spring Boot project with nothing in it, so as a consequence, I got just the generic Spring Boot starter. I added dev tools later because I got tired of restarting my app every time I made a change. I also added Lombok. Anybody here use Lombok? Okay, everybody who's used Lombok, put your hand up and leave it up. Everybody who loves Lombok, leave it up. Oh, Rob doesn't like it. Sorry, Rob. I love Lombok, especially when I'm writing code in front of people. But for other reasons, it's kind of nice too. I certainly don't like it being a dependency as part of a library I'm building. That's kind of a horrible thing. But as a developer, I kind of like Lombok. So I'm going to use Lombok a little bit tonight just for grins. And well, yeah, I'm out. So anyhow, and then down here I have this dependency management block. Just because Spring Cloud Function, as I said, isn't like real GA just yet. I got to think it's going to happen someday, but right now it's not real. I had to go toss this dependency management block in there to tell it what versions of all the different Spring Cloud Function projects need to be brought in. So it's just good old-fashioned Maven dependency management here. I suspect that one day when this does show up as a checkbox in the Spring Initializer, you won't have to do that. It'll just be part of your build automatically for you. But for today, that's how it is. And then down here, I have the Spring Boot Maven plugin. The only reason I draw your attention to that is because I'm going to change that later. I'm not going to change it here, live coding, because that'll get scary. But on the slides, I'll show you something you might want to do with that to change it for when you're working with Spring Cloud Function. And then because this is all snapshots and nonsense, I've got all these different snapshot repositories that I just pasted in there from somewhere else just so I don't have any resolution problems. Good stuff. All right. Now, ignore that. What we got here is just your good old Spring Boot Bootstrap class. It's both a configuration class as well as the main method that gets called when you java-jar the resulting project. What I'm going to do is I'm going to simply do this. Well, before I do, I should draw out one thing in the POM file I didn't mention. If you look at these dependencies, nowhere in there, aside from this dependency, nowhere in there do you see the word web. I am not pulling in Spring MVC. I am not pulling in the Spring Boot Web Starter. I am not building a Spring MVC app, and I should not have zoomed in like that. But you get the idea. And I'm not going to write an app controller or an at-rest controller because that's a different talk. In fact, I think that was actually the first talk I gave 3.5 years ago. This is not that talk. The talk I'm going to give tonight is one where I do something like this. I just create a bean, and I make it of type function, Java util function, not any of this other nonsense. You have to be careful because every so often it jumps, one of those other ones pops up at the top, and I get so confused as why stuff's not working. It's that Java util function. And I'm just going to keep it simple to start with. So I'm going to take a string, I'm going to return a string. And when I do that, I'm going to lowercase something. I mean, this could not be any simpler. And I'm going to say, well, whatever that string that came in, what I'm going to do is I'm going to string lowercase it. There we go, and I probably screwed up somewhere. Why don't you like me? Well, you can get away with, yeah. What am I doing? I tell you what I know worked. Yes, that you're right. I'm stupid. Two lowercase. Well, there's a couple ways you can do it. I'll do it the way you're saying. And I actually had it written a different way earlier today, and it worked fine. I get a little confused when I start doing static method references. I got to admit, that confuses me. When it works, and when it doesn't, I'm like, what the crap? So here we go. I'm just lowercasing. That's all I'm doing. Nothing special. So let me run that. I mean, aside from some dependencies, that's really the only real code I've got going on here. I'm just going to run that down here. Sure, I should probably save it first. You can see the Spring ASCII art. It's always nice to look at. And it looks like it's running. Give myself a nice window to work with. Curl localhost 8080 slash lowercase. Remember, that's the name I gave to the bean is lowercase. Dash D. Hello, Kansas City. All uppercase. Dash H because it is just text. It's not JSON or anything. So I should probably tell it that. Bam. And it lowercased it. And all I did was write this function. I mean, that's the gist of that code right there. And notice when you look at that function again, it's just a function. It just takes a string. It just returns a string. I don't know how it's going to be used. Yes, because I have the web adapter in play, I am able to do a curl request against it, an HTTP request against it. But if I were to take that exact same function and I were to toss it into a Spring Cloud Stream scenario where for whatever reason I needed to lowercase some data as it flowed through, that would work equally well. It doesn't need to know. Now, I will say this. It doesn't need to know how it's going to be used. This is true. It also doesn't need to be coded as a controller. That's also true. What might be a little misleading is it doesn't mean that the function doesn't need to know the domain you're dealing with. So if your domain is something richer, you can't just pass strings in. You have to pass in something else. So that's what has thrown a few people off when I show that to them. As soon as I make this more complex and more interesting, they say, well, wait a minute, you're cheating. No, I have to have the function understand the domain. It doesn't have to understand the framework. It doesn't have to understand who's calling it. So let's go ahead and continue with this. And for now, we'll leave it as a string, which is kind of nice as it is. But one of the things you might want to do, if you're have started working with Spring 5 and Reactor and things like that, you might be inclined to take a flux here instead from Reactor. And what a flux is, for those of you who may not know, a flux is essentially a timeline. If you're familiar with RxJava, it's kind of the same idea as an observable. It's a timeline. It's not a collection. That's kind of the thing some people mistake it for. It's not a collection. It's a timeline of 0 to many values. And as that time progresses, data shows up, and you can do something with it. So in this case, I've created a flux of string. I'm returning a flux of string. So probably the easiest way of dealing with this is to say n.map, and I'm going to take whatever came in, whatever the string is, to lowercase. By the way, I just now realized what I did wrong previously with the toString thing. So this is essentially the same thing, except now I'm dealing with reactive terms, which for what I'm about to show as I do this is not terribly exciting. It still does the same thing. The reality of it is, though, is it's actually able to be more scalable with regard to how the messages are handled, and how threads are managed, and ultimately how the requests are dealt with. And that's a whole separate talk I could give. But what's also interesting about it, though, is if I did pull this out, if I did extract this out and go toss it into a Spring Cloud stream, data stream, a data flow of sorts, I can actually potentially have multiple strings, multiple domain objects of some kind, coming in on one source, flowing through to a processor, flowing out on a sink, while other data is still coming in on this end. And it can be a continuous stream. Without doing it this way, without using something like a Flux, what I'm kind of hoping for is I'm going to get one thing, either get one thing at a time, or I'm going to collect a whole bunch of things into a collection and hand those off to each step. This way I could have a continuous stream, a continuous flux of data flowing from a source all the way to the sink. And it's just nice that way. But that's a whole different topic I'm tempted to get into, but I just don't have the time, because I could probably spend the entire next hour and a half or 2 hours talking about that. But just if you want to, you're welcome to use fluxes instead of just regular domain types. Well, let's dress it up a little bit more. And by dress it up, I mean, let's do something crazy. Let's add an uppercase. I know it's getting complex here. You might want to grab your drink real quick before we get started so you don't have to look down. But I'm going to do it a little differently. I'm going to come down here in this package here that I've set aside. It's empty at the moment. Yes, I should not do that. Well, trust me, over there in tiny little letters, there is a package called habuma.functions. And I am going to go in there, and I'm going to add a class called uppercase. Again, crazy talk. I don't know. You're probably just amazed at how I come up with these examples. And in this one, I'm not going to declare a separate bean or anything. I'm going to just say implements function. And when I implement the function, it's going to be a type string and string. I did. Okay, what did I do wrong? I got the right thing.
It just wants the method.
Oh, I thought somebody was telling me I did something wrong. Okay. So then it's apply. There you go. I'm going to stop listening to anything anyone says. I'm just kidding. Okay. Billy, is it? Okay. Okay. I'm going to add this apply method, and in here, you might want to take notes. This is going to get really crazy here. To uppercase. There we go.
Wait, there's no lambda. I don't understand.
There's no lambda. Because you know what? Lambdas are awesome. I love lambdas. Until the lambdas end up being about a mile long. And that's when I start feeling, once I get past a certain point, I start feeling like method references. But even method references can get out of hand if the thing you're trying to do in your function is more complex than what would fit just in a single method. At this point, I'm finding myself wanting to just write a function, but to maybe write it as a class, which is what I've done here. And so I've got this apply method, which is essentially my handler method. If you want to think of it as a handler, or in a controller sense, the handler method, or the request handler, even though that's not what's happening, the apply method is going to take a string in an uppercase, I'm going to return it. Now, if this was more interesting, more complex, I would have a good reason to do this. I'm only doing it tonight for demo purposes. But because I have that uppercase function, let me show you what happens. I'm going to do this, curl localhost 8080/uppercase -d, and we'll do it all lowercase this time. And I'm going to be really picky about my typing, obviously. If I get it wrong, it really doesn't matter, but this is what happens when you write books, as your editors beat it into you have to type things correctly. And look, it worked. Now, that's not all, though. There is a little bit more I didn't show you. The fact is, it does implement function. Yes, that's important for what I did to work. But the other thing that made it work is over here in my application YAML. I told it to go look in there and scan that package for functions. And if it found any class that implements function, it's going to expose that as well. Pretty cool. Let's make it more interesting. Now this time I'm going to show you, just because I know good and well that somebody's thinking, well, that's cool and all as long as you have strings, but can't you do anything more interesting with it? Sure, let's do one. And I tell you what, just in the interest of time, because I have so much more I want to show you, I'm going to go ahead and just resurrect something from, sorry, where's it at? Yes, that's what I'm looking at. I can't read when I'm in front of people, apparently. I'm going to pull in this tax calc. And this tax calc function is doing the clever job of calculating sales tax on products. Now, I live in Colorado, where I would really like the tax to be 0. So that's what I've done for Colorado. But it takes in a taxable and it returns a sales tax object. It's going to calculate a 0 sales tax for Colorado, but everybody else has to pay an 8 cents per dollar sales tax, just to keep the code simple. Obviously, in a real application, you might do something a little bit smarter than this, but I'm going to keep it simple for now. Just to prove that I can take a taxable, I can take a sales tax, and in case you're wondering what those look like, the taxable is just a Lombok-enabled domain type that takes a price and takes a state, and the sales tax is ultimately the same. It echoes those same things back, but includes with it the tax that it calculated. That's it. Which, by the way, is the reason I like Lombok, because I just zoomed that in really nice to a big font, and you can see the entire class right there. Whew, I love Lombok for that, if for no other reason that right there. All right, so with that said, those are in place. I think that by this time, Spring Boot DevTools has restarted the app. So this is where it gets a little fun. I am not going to use curl to do this, because I will screw it up with curl. I'm going to use HTTP, which is just HTTP at the command line, because I'm less likely to screw that one up. Tax, calc, and with HTTP, by default, everything's JSON, but you don't express it as JSON. You express it as just values, and which is kind of nice. And I am doing a post, so I guess I should probably say post up here. And then I'm going to say, if I remember how to use it correctly, price equal, let's say $10, and state equal Colorado. And look, I got sales tax of 0 for that. I'll do the same thing for Missouri. And look, it's 8 cents or 80 cents. I did the calculation poorly, apparently, but no, it's 80 cents for $10. That's right. That makes sense. So it worked. I'm able to work with more complex types. It doesn't have to be strings. Just a stupid, simple example to show you how that works. Any questions thus far? I mean, it couldn't be simpler. Now, one thing that is worth pointing out before I move off my working code here is that ultimately, when you do deploy this out to Lambda, I know this to be true with Lambda, I suspect it to be true with GCP and Azure and others, you do have to identify which function is going to be the one that's exposed, because when you deploy them there, it's a function, period. Now, you could have multiple functions in here, but one of them has to be chosen as the one. Working locally, you can get away with that, but when you go out there, you have to tell them. And there's a property you can set whose name is completely escaping me right now, but if I think about it later, I'll pull it up and show it to you, because I know a place where I have it, where you can specify this is the function I want you to expose. If you don't do that, and I've experienced this, if you don't set that property, but you do have multiple functions, what's going to happen is, at least with AWS, is it's not going to accept it. It's going to error out, and it's going to tell you, I don't know what you're talking about. There's several here to choose from. I'm not going to pick for you. Those aren't the exact words of the error message, but that's kind of reading between the lines. That's what it's saying. I'm not going to pick for you. You have to tell me. All right. So with that said, let's go back to the slides. And for the next few slides, I got a few things that are essentially what I showed you up there, but a few extra things as well. So once we deploy this thing, as I said, we have our choice of AWS Lambda and Apache OpenWhisk. There's already adapters out there for that. I have not used the OpenWhisk one, so I can't speak to it at all. I have used the Lambda one quite some little bit, and I'll even demo that for you a little bit later. There is one for GCP that's being worked on. It's actually part of the, if you go look at the GitHub repository for Spring Cloud Stream, you'll see the code in there for it. The README file makes it pretty clear that, hey, we're still kind of working through kinks on this, but have fun. Knock yourself out. I have just 2 nights ago, because just on a whim, I did deploy something to GCP written in Spring Cloud Function, and I was shocked that it worked. but I will say that the steps to get me there, I was a little fuzzy on what I did. I was just basically copying what someone else had done. So I'm still kind of getting my head around how that works. But it does work. And then Azure. I know that there's work being done on Azure. There's interest in doing that. I have not seen that work, but I assume it's there. There's obviously some interest there as the other big winner aside GCP and Lambda for deploying these things. And as I pointed out, the way I've been running this so far is running the local adapter, or the web adapter that's good for running locally. That's what I've done so far. It's essentially a serverless function platform, open source thing you can run. I've never used it. You can, as my understanding, you can run locally. You can also probably host it somewhere. I know almost nothing about it. I will say this, though. I was headed somewhere with this. It was very important. There is, inside of Spring Cloud Function, there is a set of scripts. In fact, you'll find them quite conveniently located in a directory called scripts. And they will, I've only played with those a little bit. They're interesting, but they're kind of that whole running it locally kind of feel to them. They don't feel like something I would do in a real world, but you have the ability to essentially set up a serverless platform locally. You can register your applications with it, and you can run them locally. And they're pretty cool. How they work under the covers, I've not bothered digging in too much. But I've played with them a little, but they're interesting. Feel free to knock yourself out on that. I'm not going to talk about them past this slide, but there are some scripts to help you get started on this without even pushing it to AWS, if you want to do that. So I already talked about this, so we'll skip over that. The dependencies you need, I walked you through the POM file, so we'll skip that. But the one thing I will mention, because I guess I didn't show you in the IDE, is at very least you need that first one. That's kind of the core of Spring Cloud Function. Now, I didn't use that. I had the Spring Cloud Function Web, which transitively brings in that one. But the web one is what gives you the local adapter. And then the third one down here is something I'm going to show you here in a few slides. So it's optional. You don't need it. But if you're going to use it, there it is. Incidentally, you are probably not going to use any of these except in development. You're probably only going to use these in development. When you actually go to AWS or you're going to GCP, you're definitely going to take out the web one, and you might take out the compiler one, because what you're going to do instead is use one of the adapters they're going to run out there. You're not going to need the local adapter, and in fact, because of some of the upload limitations on what you can push to Lambda, the web one actually makes your jar file a little too big, and so it's just good to get it out of the way and take it out. So just by the by. You don't need it. It takes up space. You're going to take it out. We'll talk about how to do that in a minute as well. I'm sorry?
I was just going to ask you to use maybe profiles to do that.
No, you do another weird trick. I'll show you. I mean, you could probably use profiles to do that, but I'm going to do something different. And then this is, again, the dependencies. I already showed you the dependency management as well as the version properties. Okay, I already showed you this, but just kind of walk through the slides a little bit. You can write a simple Lambda function. Previously, a couple slides back, I showed you just a string to string. This is a same kind of thing. This is just getting a string, returning a string. You can do it reactive with fluxes. You can take a flux of string and return a flux of string, or take a flux of whatever and return a flux of whatever, and just use whatever flux operations in the middle you need to get the job done. You can use a supplier. So a supplier is essentially a function, except that it doesn't take any input, it just provides output. So one of the coolest things is, I mean, this right here is interesting. It's essentially about as simple as you can get. It's the hello world example of doing this. But where it gets even more interesting is if you were to use a reactive Lambda supplier, and even this one sucks. I should have changed this slide earlier today when I realized how much it sucks. It gets better. What you can do is you could even do something like, even for hello world scenarios, you could do a flux.interval. So every 1 second or every 10 seconds or whatever, it emits a value. And so just even for demo purposes, a flux that every so often emits a value would be great for using fluxes. And especially if you're working in the context of Spring Cloud Stream, where this is a source in a Spring Cloud Stream. So the way this works, by the way, I don't think I have any examples any further down, so I'll go ahead and tell you about it right now. If you have a supplier, and if you have the Spring Cloud Function Stream, I think that's the name of the dependency. If you have that in play, essentially a supplier gets exposed as a producer, or not a producer, source. If you have a consumer, it becomes a sink. And if you have a function, it becomes a processor. I'll be honest, the reason I don't have an example of this is because while I have seen this work, I have written code that makes this work, I could not get my code to work today before I came in. So I said, okay, we're going to ditch that one. But it might be something to do with how I shifted to a different version along the way. But I don't know. It just wasn't working for me, so I decided to ditch that. But essentially, again, a supplier becomes a source, a consumer becomes a sink, and a function becomes a processor in the Spring Cloud Stream terminology. You can discover functions, as I did. Oh, I forgot to tell you about that, the function scan. This is the other magic I put on there so it would discover it. I said @function scan on my main configuration. I wrote a class that implements function, and then I told it what package to go scan those for. And you can scan for those if you'd like. I've also learned, I don't know why I would do this, but I've also learned that if I just simply created a class of function and annotate it with component, that also works. So it comes out, it works either way. I'm not really sure why you would choose one over the other, but function scans the more, I guess, focused on functions, I guess. And now this is the one that requires that compiler dependency I spoke of earlier. And this is a very contrived, stupid example. I will tell you that up front. If you dig around in some of the samples that come with Spring Cloud Function, you're going to see a few examples where they make it slightly less contrived. Not much, but a little bit. And so what I've done here is I've created a function, a bean of type function that takes a string, returns a string, just like I've been doing all along. And in fact, it does the two uppercase, just like all I've been doing all along. The difference is that the actual lambda that I'm applying is kept in a string that I compile using this function compiler, which is, in this example, pretty stupid, because I've actually written more code to achieve the same thing. But one of the things that you might do with this is extract that hard-coded string that's up there on the fourth line, extract that to something else, into a properties file, into a YAML file, to a database for all I care. Maybe you fetch it from some service somewhere, but somehow you obtain this string, you compile it, and then that's what functionality you're providing. And that's interesting to me. I've not yet come up with a reason I'd want to do that, but it's interesting to me. It's the same kind of story from just the Spring Framework itself. And Spring Frameworks all along, or at least since Spring Framework 2.0, you've been able to drop a Bean Shell script or a Groovy script or I think you do JavaScript somewhere out on either on the class path or even just out in the file system, and you could go find that thing and essentially expose it as a bean. It's really interesting, but I've never found a practical use for it. So this is kind of the same thing. I'm sure there are. I'm not saying there's not. For me, I haven't figured out, okay, what compelling reason would I want to extract this when I could just deploy it as an individual function. I don't know what the benefit would be, other than I guess I could change it a lot quicker. Although if this is deployed as an individual function, I could also change it pretty quick, so as opposed to the entire application. So I'm still a little fuzzy on what the use case there is. I don't know. I think what bothers me about it most is that it's a string. And testing strings is hard. Testing functions is easy, but testing a string that contains function code is a little harder. And that troubles me a little bit. But again, I'm not saying there's not a use case for it. I'm just saying think about the trade-offs you're making when you do that. Of course, you can do the same thing with reactive. It's essentially the same story I've been telling all along. You can still do this even if that lambda inside of it is dealing with fluxes instead of just strings or integers or domain types. All right, when it comes to deploying this stuff to AWS Lambda, here's what I have done. It's not my brilliant idea. I'm copying it from others who have done the same thing. Is the deployment jar has to be shaded. What shaded means is it essentially has to have all the dependencies that it's carrying exploded out, just like all the other .class files that you've written are just part of the jar file. So when you build a Spring Boot application, normally what you end up having is a jar file that has your code in it, sure, but it also has a directory called boot-inf, and in boot-inf you're going to have all the jar files that your application depends on. The thing is that Lambda doesn't like that. And as it turns out, I've learned GCP doesn't like that either. And so what you're going to have to do is create a shaded jar file which essentially explodes those things out. And that's easy enough to do by adding the Maven Shade plugin. And you put this classifier name on there so that the resulting jar file actually is whatever your name of your project is, -aws.jar, and you know you're dealing with a shaded jar. So good stuff so far. That other thing at the top is the weird part. And the main reason it exists is because if you don't have it, then the regular jar file, the process of building the regular jar file gets in the way of building the shaded jar file. There may be other reasons, but I've observed that they get in each other's way because in the course of creating a shaded jar file, we explode everything out into this temporary directory in Maven in the target directory. And then the same's true to some degree of the regular jar file, the non-shaded jar file. We don't explode everything out, but we still have in there, we have directories that have just the raw jar files in it, and they tend to get in each other's way when it comes time to actually create the jar files. The ones that actually have our dependency jar files in it somehow sneak over into what should be a shaded jar file, and those things that are exploded somehow sneak over into the other one, and nonsense happens. But yeah, profiles might be a way to deal with this. But the simpler way, just to get started with, is just toss in this Spring Boot thin layout in there. And just to give you some idea of what that does, it is experimental. What it does is when you build that Spring Boot application, you have all your dependency jar files in this boot.inf directory, right? So what you end up with is a executable jar file that's huge. It's your code plus all the other code that it depends on, which troubles some people. I don't know why it troubles them that much, but it does trouble some people. And the thin format doesn't do that. The thin format has your code in it. It has just a tiny little bit of extra libraries in there that when the jar file is run, the very first thing it does is it tries to resolve all those dependencies at runtime, not at build time. And so what you end up with is a tiny little jar file. Like we're talking in terms of kilobytes as opposed to megs or gigs. Very tiny little jar file. When you run it, it then goes and fetches at runtime everything it needs, which is neat, but again, I don't care for that for a number of reasons I won't get into here. But in this case, I kind of like it because it does, as a consequence of doing that, it doesn't try to put all those jar files into the main build deployment unit. As a consequence, there's no chance they're going to get in the way of building a shaded jar file. They stay out of each other's way. Once you have it ready to deploy, once you've built this shaded jar file, well, there's a lot of ways you can deploy this. For some of you who may have worked with AWS Lambda before, you know how easy it is to just go into the web API or the web UI, fill out a form, answer some questions, upload a jar file, and wish it luck, right? And I'll show you what that looks like in a minute. But what I've learned from experience is every time I've bothered to take a screenshot of what that looks like, Amazon goes and changes the UI. Every single time. I am not joking. It's not hyperbole. Every single time I've taken a screenshot of that, give it about 2 days and they change it. I stopped taking screenshots and it has not changed since. I am not joking. So I'm going to stop making, you're welcome, okay, because apparently I have that kind of power. Instead, I tend to use, even though I don't mind using the web forms, I tend to use the AWS command line. It's, if nothing else, it's CI friendly. If you have a build script, you can just invoke it from the build script. The website's a little trickier to do that with. But you basically say, hey, I'm going to create a function. Here's the name of my function. Previously, I've set up some role that I'm going to associate this. So here I'm associating some role with it. Here's the zip file I want you to upload, specifically the jar file that the AWS jar file, the shaded jar file I'm building. Here's this handler, and there's a lot of different things you can do with handlers. There's actually 2 or 3 different versions of this, plus you can create your own. I'm just using the Spring Boot Stream handler. It's a piece of cake. It works fine. I'm saying, give it a description of my awesome function. The runtime is Java 8. The region is US East 1. Timeout and memory size I'll talk about in a second. And then finally, publish this. Make it live. Don't just upload it and wait. Go ahead and make this thing run. But you can also use the web interface if you want. Now, about that timeout. That timeout is 30 seconds. You can set it to whatever you want. But at 30 seconds, it's kind of a nice answer. What that means is that once an instance starts up, it will remain running for 30 seconds as long as people are calling it. As long as someone is invoking it, it will remain up and running for 30 seconds. After nobody has invoked it, then that instance goes away. It shuts down. And so you could scale up to 100 instances, and they're all really busy right now, and then suddenly you start losing traffic, and maybe only 50 of them are busy. The other 50 have 30 seconds to get traffic, otherwise they start getting shut down. And eventually maybe you get no traffic. The remaining 50 will eventually shut down after about 30 seconds of no activity. That's a good thing, because now you're not getting charged for time it's not being invoked. The 30-second time period is basically giving it so that it doesn't do its job and go away immediately, and then you have to wait for it to start up again. It's giving it some time so it's ready in case somebody that comes along pretty quickly, but if nobody comes along within 30 seconds, I'm going to go away. This kind of works like my kids. I ask them to do something, they do it, and about 30 seconds later they disappear. And I have to call them downstairs again to do something else. And then they disappear again. It's exactly the same scenario. Memory size. Here I'm giving it 1024, but I have learned you might want to adjust that for a lot of reasons. First off, if your function needs more memory, just because it does, you can update that, but the AWS has a limit of about 3 gig. So that's about as high as you can go, is whatever that is, some number. I can't do math tonight, so I'm not going to try. But you can update it to about 3 gig, and that's about your upper limit for AWS. The idea is you're not deploying full-blown applications out there. You're not deploying monoliths out there. You don't need that much memory. If you find yourself needing that much memory, maybe functions aren't for you. And so there's another reason you might want to up it, is even if you don't need that memory, especially with Java applications, the cold start cost of a JVM app is a little bit kind of ugly. So just for a simple Hello World app that actually, I say it's simple, it's actually more complex than any of the stuff you saw in the previous slides, but a relatively simple Hello World app that cold started has taken about 20 seconds to start when I set it at 1024. If I set it to 3 gig, I can get it down, just by doing nothing more than that, I can get it down to about 4 to 5 seconds startup, which is still an eternity, but it's better. And then there's other tricks you can do to avoid having that cold start. You can up the memory if you need to. That's one trick. Not up the memory, up the timeout. The idea is if it doesn't go away as quickly, maybe it won't be gone when you invoke it the next time, and you don't have a cold start cost. But now you're paying for it if it doesn't get called. You could also cut your bills down by setting the timeout lower, but now you have to pay for the cold start cost every time. So there's some tricks you can pull. There's also some tricks you can pull within Spring Boot itself. Not every auto configuration is required in Spring Boot, so it is possible to go tell it to ignore certain auto configurations. That will buy you a little bit. Not a lot, but it will buy you a little bit. I have managed to get that same Hello World app down to about 2.5 seconds on average. Still an eternity, really, but it's so much better than the 20 seconds I started with, an order of magnitude better. So by doing that, plus updating the memory, skipping some of the auto configs, I got it down to about 2.5 seconds, but it was just dumb little stuff. And I also learned once you start ignoring auto configuration, like if you're not using Rabbit, you don't need Rabbit auto config, so just disable it. But I also learned that once you get past the first couple of them, you've bought yourself about as much benefit as you can get. Adding more doesn't really help much. I'm not sure why. It seems like it would help more, but it doesn't. Yes?
Mostly be bored and cycles, but have you actually done much with like Java clients to install?
I have not. That also might help.
So the first request that comes in is going to take 4 or 5 seconds. So
It's going to take
work in reality if you're running RESTful web services that need to be responsive. Do you not pick services, or do you need to have it?
It depends. I would say ideally, you probably, if you're calling this from something that has to be responsive, you're not very tolerant to cold starts. And so you need to come up with either a plan to keep these things alive longer, like with a timeout, or something else has to happen. Maybe this is not for you. You have to kind of think through the situation. In the case of stream processing, you may be a little bit more tolerant to the cold start. And so you have to decide whether that's a good fit or not. There's also interest. I mean, there's a great deal of interest, not just from the Spring team, but from everyone else in the world to make that cold start better. Because it's not just a Spring problem, it is a JVM problem. And there's interest to make that better. So hopefully someday we won't be talking about this anymore. But Rob has some thoughts.
I think there's actually experimentation with some of the providers to actually pool the JVM. And
Yes.
kind of like basically dev tools where you don't have to start the whole JVM. It's just
Right. For some reason, I thought that's how it already works. But
I can't speak authoritatively on it, but I believe there's work going on in the Spring Cloud function to do that within their abstractions. But I don't know if you know any more
You've basically said something that I had forgotten, but that's what I had heard. I remember Mark or somebody mentioning that. Yeah, so that'll also make it better. Everybody's interested in solving this problem. I mean, even Amazon doesn't want you to have to write this in Node. Even Node, if you were to write these functions in Node, even Node has a cold start cost. It's just not as hefty as a JVM cost. But everybody wants it to be better. We're just not there yet. That's kind of the bummer part. I mean, I hate to bring you all down after I've given you all this information, but it's just the way things are today.
This will be great in C5.
Yeah, it'd be great. Bank on it.
It also has a bunch of options for like setting timers where it will spin up like 10 of them at like 7 a.m.
So
If you're talking about like actual end users who are in contact with it, they have quite a few of those options.
Okay.
Just like the Java users group, there's an Amazon developers user group that covers that and almost everything too.
Yeah. Yeah, I suppose you could do, even if the platform doesn't do anything like that for you, there's no reason you couldn't just schedule something at 7 a.m. to like make a hit so you get it up and running, and now when the traffic starts coming in, you're ready. I don't know. All right. As I said, it's called function as a service, or FaaS. It's not called fast. If it goes idle, it's going to be slow to wake. You can manage that with more memory, manage it with timeout, everything I just said on that previous slide. This is what this is saying. And there's other trickery you can do, as we've discussed. Hopefully this will get better. Hopefully I don't have to keep bringing everybody down at the end of this talk. So hopefully I can bring you back up here in a second with this one.
Sorry, I have another question about
Sure.
the one before this. So you have function name and my function. Is the Spring Boot string handler matching that my function to a bean, or is that just the name?
No, that's just the name it ends up as.
Okay, so does this one only have one function?
It could have multiple ones, but there's a property you have to set to tell it which one you want to expose.
In the actual jar file.
Yeah, and I don't remember what that function is off the top of my head, and unfortunately the state of some of the Spring Boot stuff in Spring Cloud Function doesn't do code completion. So. Yeah. I'll look it up. I'll show you in a minute. But before I do that, let me show you this, just to give you an idea of what that looks like. I've actually played around with some of this quite some bit. And if I go to AWS, make sure I'm logging in at the right spot. Probably not. Oh, there we go. Does anybody remember my password? It's password. Password. No, it's not. If I go over to Lambda, I'm going to pick on the lowercase one. I think that's the one I actually left in a decent state where I could share what's going on. I have no idea. I don't remember attaching Dynamo to this, and I don't know why it's attached. Maybe it's something AWS did for me, or maybe I magically did something when I was, it was 2 in the morning. I don't know, but ignore that. But essentially what I have is this lowercase function here, and this lowercase function is just that lowercase function I showed you before. Nothing more, nothing less. It's just takes a string, returns a string, lowercase is on the way through. And look at me zooming. And so let's try it this way. That's slightly better. Not much, but slightly better. And so it's just the lowercase. It doesn't know how it's going to be used. What I did, though, to make it be aware of how it's going to be used, among other things, is I attached this API gateway to it. And when I attached the API gateway to it, that suddenly gave it an HTTP front end, so that I can do things like this. If I can go find my cheat sheet that has the stuff I don't want to remember in it. This one right here. Okay, go back. Where's my window? Curl that. And obviously, I screwed up somewhere. Oh, yeah. Lambda's funny this way. So it's waking up. I got that cold start. It's actually taking longer. This is my unoptimized version, clearly. There you go. So the function was written as just a function. It's a bean of type function. It takes a string, returns a string. That's it.
It should be super responsive, right?
Oh, yeah, it should be really quick now. No cold start now. About 30 seconds from now, it won't be. And actually, the 30 seconds is sort of guidance. I've actually seen it still awake about a minute later. I think it's up to the platform to decide. But after 30 seconds, it's fair game. The platform can take it down. But yeah.
Well, I'm sorry. Will it take it down if it's in processing, or does it always allow it?
No, it's in the middle. It's not idle at that point. It's after it goes idle. It's 30 seconds after it goes idle. And so I had a thought there, but I can't remember what it was. Oh, yeah, it's essentially what I was just saying. It's just a function. I deployed it as a function. I happen to have put an API gateway in front of it. Consequently, I can make an HTTP request to it. But I could take that exact same function, make it part of a data flow, and it would uppercase something as data comes through it. I could take that exact same function and attach it to some other front end, and it would deal with that input and output according to whatever that front end is. But let me show you another one I've got. And this is my favorite one. Hands down, it's not my favorite one. I actually got a better one than this, but this is the one that's most fitting for this talk. This is a bean of type supplier. It means it doesn't take anything, it just provides something. Although it could take something, it just doesn't. I'm returning a Lambda that takes nothing and does a bunch of stuff. But the result is I'm returning a speechlet response envelope. And as a consequence of that, there's also some stuff that's happening here you don't see. There's a service, or I say service, it's just a class that offers a method on it where I randomly pick something. But as a consequence of that, I can do this. This is the funnest part right here. I love this part. Bear with me while it probably has a cold start too because it's been a while. I'll turn it up and hold it close to my microphone so everybody can hear it. Ask Lyrically to give me a lyric. Cold start. Wait for it.
Just a small town girl, living in a lonely world. She took the midnight train going anywhere.
Likewise. Ask Lyrically to give me a lyric.
See the stone set in your eyes. See the thorn twist in your side. I wait for you.
Okay, see, it's an Alexa skill, essentially. And because, as I said, when I put that lowercase one out there, it's just a function. It doesn't know how it's going to be used. Likewise, when I push this out there, it did not know how it's going to be used. Yes, the domain of speechlet response envelope, that much I had to deal with. I had to deal in terms of what Alexa knows how to deal with. But that's the only specific thing I'm dealing with. I could put an HTTP gateway API in front of this and curl it and get some JSON back with the appropriate data in it. It doesn't mean that it has to be handled as an HTTP request. It doesn't mean that it has to be handled as an Alexa skill. It just is. And that is exactly the same code, plus a little bit of magic behind that randomly picks a lyric, but that's about all it does. Nothing terribly exciting in that code. That is what is backing that skill that I just wrote, or that I just invoked. So with that said, this is exciting to me. This whole Spring Cloud Function stuff is exciting to me because this is exciting to me. And this is the very first, let me take that back. It's a lie. This is the second Alexa skill I ever wrote. The first one I wrote, I did it by the book. I followed the tutorials that Amazon gave me, and I wrote it in Node. And it was good, and it worked. And I felt so powerful because I was able to do something that even my children can talk to, and it'll respond. They don't understand what I do day in and day out, but they could do that. And then I thought to myself, and literally this thought went through my head for a couple of months in a row before I ever took any action on it. I said to myself, if I can do that in Node, can I do that with Spring Cloud Function? And it's one of those I just never got an opportunity, the time to sit down and give it a shot. And I was afraid that what I was going to need, the reason I never found the time is not that I didn't have any free time. I had free time. I was afraid I was going to need several hours of free time. I wrote this in about 30 minutes. And the longest it took me was to get my head around the speechlet response envelope and what that JSON need to be returned look like. And I realized pretty quickly, somewhere in that 30-minute time period, that the Alexa Skills Kit already has Java support for this. I just didn't like what they were doing. I wanted to do it in Spring Cloud Function, but can I reuse some of their types? And that's what I did. It's Apache license, so sure I can. I can do whatever I want to with it. So I decided to use their types, and this worked. I mean, I kid you not. From the time I decided I'm going to sit down and do this, I gave myself about 4 hours to do it. 30 minutes later, it worked, and I don't know what I did after that. I'm not sure I don't remember what I did with my time. But 30 minutes later, I pushed this out to AWS. I attached Alexa to it, and I asked her to give me a lyric, and it just worked. How freaking awesome is that? So I geek out over things like that. I geek out when I'm able to write code that does something outside of this thing here or outside of the cloud. Yes, it's running in the cloud, but I can expose it through Alexa, or I can expose it through, like, I also like messing with Sphero robots. And so anything I can do like that, my kids get excited about too. And that's even more cool because I get them kind of geeking out at it. My wife doesn't like me making the kids nerdy, but that's just the way it is. So that's it. I guess I do owe you this because I did say I was going to give it to you. If you go to github.com/abuma-spring skills, it's a little project I'm working on that's got even more interesting examples in there that I'm working on. But for the lyrically code specifically, I did say what I was going to share with you. Oops, wrong direction. I did say I was going to share with you that one property. I'm not going to zoom in. There we go. It's function name. That may have changed since this was written, this exact one was written like at milestone 1 of Spring Cloud Function. So don't be shocked if that's no longer the name. It may be something like spring.cloud.function.name or something like that. In fact, I kind of think it did change. I just don't know that. But that's the one that identifies, even if I had hundreds of functions, that's the one that AWS is going to expose. So with that said, I'm done. Thank you. Any final questions? Anything else?
Is this in your new book?
No, this is like totally outside the scope of that. I might, if I really feel compelled to do so and I have space and time, because I'm bumping up against both page count as well as time. But if I can find the space in the book and if I can find the time, I am compelled to talk a little bit about Spring Cloud Function itself. Yeah, but I'm kind of doubtful it's going to happen because I am getting close to a deadline and I'm also getting close to a certain page count. And neither of those I can push too far.
That's sort of old new book.
No. I say this every time I write a book. I'm retiring from writing. I mean it this time.
Did you mean it last time?
I did. I really did. Yes.
I guess two. I guess so. The first one is, so would you see serverless or functions as like a general thing, or would you think it's more of like a very specific thing? Like I can see it's like would be very useful for like say a table or something like that. You're going to maybe use it for one, but like you may still really have your full microservice, but like okay, I get these few things.
I see it exactly. I mean, I could be picturing it wrong myself. Maybe other people have different opinions on this, but I do picture it as very specific use cases. And even then, I wouldn't necessarily say it's necessarily table-based or anything like that. It might be something of a matter of, it may be something more interesting, more complex. There may be a database behind it. There may be all sorts of stuff going on. But if I'm only invoking this thing every so often, why am I paying for the server for that? If it's, there's two things that really make functions appealing to me, aside from just the fact that I can put an Alexa skill in front of them. There's two things that make them appealing. One is if there's a good high likelihood I'm changing them frequently enough that I don't want to make them part of a service that I also have to change frequently. So they give me the flexibility of pushing things out a little bit, kind of on a moment's notice almost, if I need to change something. The other thing that makes them compelling is when I do have something that is not invoked frequently, that it is invoked at specific periods of time, or maybe I don't know when they're going to be invoked, but when they tend to have fits and spurts of activity, and I don't want to pay for the times when they're idle. That's the other thing that makes them compelling to me, and kind of the sweet spot is when it's both of those. I'm likely to change it frequently, but it's not likely to be called frequently. Then that's kind of the best case scenario. That's when you start seeing those cases, that's when functions really feel good. If it's something that's invoked frequently, you're not going to get the cost benefits out of it. If it's something you're never going to change, you're not going to get as many cost benefits from that either. So it may be better off just doing a standard microservice with those.
And then the other thing is, so you always talk about like it's easier to understand conceptually, it's easier to understand or easier to test with a smaller unit. But like when it's kind of in like microservices, then it could be a little bit more function. So also it's not really going to be a general solution. It could be have like millions. It's like there's the kind of complexity once you
Oh, yeah, certainly, there's certainly a case for still doing large-scale testing. It's just that you don't have to give it quite as much attention as you once did. Because now, as long as you have done the fine-grained testing, and as long as your contracts are in agreement with each other, and when you test each one of those, you test them with mocked contracts, then you can feel fairly confident in the real world it's gonna work just fine. But so you don't have to. It doesn't mean you don't have to test it in a real cloud scenario. You just don't have to do a super 2-month QA process before you release it. You can do it more quickly. You can do fairly fine-grained smoke tests across the whole thing. Is it behaving the way I think it does? Call it good, and if you find out later you were wrong, you add that to your test suite, and then the next time you do that other little test. And you don't have to do this big complicated test process. You do a real quick and dirty smoke test, and you call it good, which essentially leads to a more agile project. You can get your stuff out there quicker. You don't have to wait. I think of the worst case scenario is a project I was on my very first project in the professional world right out of college. I kid you not, we would spend 6 months developing and 2 months in QA. And 8 months after we came up with an idea, we would go into production. I'm talking about, maybe 8 hours as opposed to 8 months. In some cases, maybe 8 minutes. It just depends. You could literally go from idea to trying it to realizing, oh, that was a bad idea and taking it back out all in the course of an hour. And you can be more fluid with your development and deployment as opposed to waiting several months at a time to get stuff out. But again, I think your question leads to is you got to test that. You can't just say, whoop, ship it, it's done.
Yeah, like, I mean, I kind of think it's just kind of like if you're having a lot of functions, or even like also a lot of microservices, like you may start getting some things that may be more difficult to necessarily test until you have either a production environment or actually in production where you're a lot of network traffic, you may be doing a lot more connections. I just didn't know, you'd be stalling the uptick in that in any of your personal teams using a lot of functions, or with maybe,
I know it exists, and I know people are doing that. The work I'm doing is primarily building the stuff behind the scenes.
Yeah.
And so, we certainly encounter some situations where some of the services we're offering, we don't realize they're going to be a problem until they get out there. But and it would have been better had we tested them in the actual environment, but we just don't have that luxury.
Yeah.
And so, because the stuff that my team develops ultimately could end up on anybody's cloud. And we don't know who's going to use it. We don't know if they're running their stuff on AWS or GCP or Azure. We don't know. And so there's always surprises. Azure has been our biggest surprise for a number of reasons, but because they do some interesting things with data sources. After that, they basically, if a data source gets idle, it's not just pooling, it sort of just disappears for a moment. And we had some surprises with that one, but we just didn't anticipate that. And so, yeah, you're always going to have those surprises, but when it comes to actually testing it in the real world, we've learned from that, and not for everything, we don't do a full-blown suite of tests against it. We do a decent set of smoke tests against several environments, so that when we push something out, we're fairly confident, but you can never be 100% confident.